Hello, we're going to finish up chapter 11 here on multi-layer switches and their capabilities. Now, in the past, we've talked about switches working at layer 2 of the OSI model. There are a class of devices, and we call them multi-layer switches, that can work at multiple layers. So again, commonly, switches are layer 2. I mean, they are a layer, this is a standard switch. At layer 3, we discussed that earlier in this chapter. These are standard switch. Layer 3, we do have these switches. These are switches with routing capability. However, we do have other layer switches that can operate at layer 4 and at layers, and some even operate at layer 7. When we talk about a multi-layer switch, multi-layer switches can have different capabilities. Again, as we talked about earlier, they can route. So this is layer 3. They can provide quality of service. And this can either be layer 3 or layer 4. They can act as load balancers. They can perform port bonding. And they can act to protect networks. So, kind of like firewalls. So let's start off with acting as a load balancer. So what is a load balancer? Load balancer basically is we can have our layers. Sorry about that. We can have our switch here, and this is again a multi-layer switch. And we have a bunch of clients out here that want to connect, and of course this is a cloud. And they want to connect, and they're going to connect to a web server. Could be something high traffic web server, something that requires a lot of is expecting a lot of traffic. Something that popular videos or real popular websites, sites that do a lot of broadcasting, something really popular. And what we do when those situations happen, we have a bunch of servers out here, and these servers can only handle so much of a load. I don't care what kind of server you get, how big it gets, they can only handle so much load. You got a bandwidth requirements here, you've got latency requirements, there's a CPU here, they can only handle so much. So with a load balancer, what happens is as systems come in, and there are different types of load balancers as to what their capabilities, how they load balance. But basically this switch comes in, and the first guy that comes in, he's redirected here. Second person that comes in might be redirected down here. And then the third person might be the third workstation might be redirected here. So we actually load balance. Now, what is important about this is these devices here, these servers, they all must be running the same process. So if it's a web server, so they have to be running the same website, the same pages, etc. They can't be running different. You can't have this one serving out stuff for sale, where this one's serving out social media, and this one's they've got to be running the same. Again, that load balancer is going to send these things through. Might send them in around what I described here as a round robin. They might be sending them resources. These, even though they're the same servers, this one might be a very, very new server, something with really some the latest CPU, 3.1 gig servers. I don't know, 128 gigs RAM and a few terabytes hard drive space. This one might have a 2.1 gigahertz processor, and down here, and this one might have maybe an older 1.5 gig processor with very little cache. And this load balancer, because they're running basically the same website, is able to take these and you can share them. Now, in a situation like that where this server, and this server have different capabilities in terms of processing power, etc., the load balancer here might actually can detect that, and it will actually determine the actual CPU load on this machine, and this machine, and it knows which one is can handle what. So it instead of a round robin where this machine went to this machine here, went to one device, this one went to another, and this went to a third, it will actually send say three requests to this device here, 2 requests here, and 1 request here. So again, it's there to manage the load of the network. How are we going to do this? This is actually really weird. No. All right. Let's do it this way. I wonder if I can select. All right, the next type of switch we're going to talk about is a content switch or content filters. Now, these specifically work with web servers. we basically read incoming HTML requests, and from here they can issue SSL or TLS certificates. We can issue cookies, and we might respond in other ways. So what we're trying to do here is they're actually removing workload from servers. Other things switches can do, they can perform quality of service. Now, when you hear quality of service, you're going to hear you're going to see the term QoS. Quality of service, also called traffic shaping, is used to prioritize traffic. And I've talked about this in the past briefly, but when we're talking voice or video on a network, voice traffic or packets have to get a constant priority. And in here, it's okay if we drop a packet or two. What's important with voice is that the packets arrive at a very specific times. So again, it's very important that with voice traffic that traffic gets there very, very specific times. It keeps the voice quality up. Again, keep in mind, within voice, we can drop a packet or two, people aren't going to care too much. This is not the case with, say, data like FTP. If we drop, with FTP and HTML or other packets, it's very important that all the packets get there at the final destination. Again, they don't have to get there at the same time, they don't have to be quick, etc., but you cannot drop any packets with, or we can't lose any packets with something like FTP or with HTML or HTTP, other protocols. With voice, yeah, we drop a packet here and there, it's going to be okay. Keep in mind when we're talking, as we talk, there's a lot of dead space, a lot of white space. We're just not saying a whole lot every second. So if we, the packets, even dead air, have to arrive at a very specific time. So they may, every 14 milliseconds a packet has to arrive, whatever that time may be. So again, it's very important that the packets arrive at a very specific time. So they have to, X milliseconds. So just keep that in mind. They have to be there. And we can we use quality of service to actually prioritize that packet. So when we do this, data packets can be queued. Again, we're just putting them in a line. So FTP, web traffic, email traffic, it just gets stuffed in the queue. We're not talking we're not talking hours and days. We're just talking, it gets put in a very specific memory, and then when the voice traffic gets its packet through, the data transfer can start up again. And one of the things we're hoping to do this is manage bandwidth. One of the things we can also call this is traffic shaping. And here we are attempting to guarantee bandwidth or latency. So latency is actually how many milliseconds apart each packet is going to arrive. Another feature of switches is called port bonding. Now, in port bonding, we combine two or more ports to increase bandwidth. So, for example, here I might have I might have a switch, and in that switch I can have a server, and this server, this might be 1 gigabit per second. You're going to kill me. There we go. 1 gigabit per second port, and for whatever reason this port is we need additional bandwidth, so we take another connection, put this to the switch, and this is also 1 gigabit per second port. Now, in normal circumstances, before port bonding, this would have IP address 1 and this would have IP address 2. Well, with port bonding, we actually take these and we combine them to give us an effective bandwidth of 2 gigabits per second. And depending on the operating system here you have here and the switch you have here, getting 4 or even 8 ports bonded is not unusual. So again, in this situation here, we combined two 1 gigabit per second ports to give to get a 2 gigabit per second transfer. So we're combining them to just double up. And again, depending on the operating system here and the switch capabilities here, you can get 2, 4, or 8, sometimes even more, but 2, 4, or 8 is not unusual to get that bandwidth. Again, that saves you the hassle of having to upgrade the switches or the servers when this happens, when you need more bandwidth. You say this switch is an older switch or a switch that only supports 100 megabits, and you need 500 megabits. So you might be able to combine, and it's usually an even number, you can't put 5 out there, but you can combine maybe 6 or 8 ports and now have that additional bandwidth. Now we also have the capability of within our network or with a switch of network protection. When we're talking about network protection, as a general rule, there are several areas that we can be looking at. One is intrusion detection or prevention, prevention. Think of these intrusion detection and prevention. In this case, it's on the wire. We're analyzing traffic as it's passing between certain ports, looking for known malicious signatures. And then if in intrusion detection, if it sees a known malicious traffic, it will send off an alert, usually with an SNMP trap. Again, think back a couple chapters, and say, hey, there's a problem here. I'm seeing traffic. Intrusion prevention sees that traffic and has the capability of stopping it. That's the difference between detection. That's the difference between detection and prevention. Detection has the ability to see the traffic and alert. Prevention has the ability to stop the traffic. We can mirror ports or span ports. Now, this is something specific. We use this a lot we put some of these intrusion detection and prevention systems through span ports. So here we have a switch, and in this switch we might have a server, could be a web server for example, and over here in this port we have some kind of a security device. It could be, we'll say an IPS, or an IDS. It could be Wireshark, some kind of monitoring device. Now keep in mind this is a switch, so if we have something out here and it's communicating with the server, remember it's a layer 2 switch, or multi-layer switch, doesn't make any difference. What we're seeing here is traffic's coming from here and going over to this server and then coming back to that server, and it's bypassing our IPS, or intrusion prevention system. So what we do with a port mirror is we tell the device, whenever traffic gets to this port, send a copy to this port. So we go back to this traffic is now coming here, and then a copy is being mirrored down to our IPS. And when the traffic goes back this way, and again a copy gets mirrored over here to the IPS monitor, and then the IPS monitor at that point can make or whatever device we have here can actually monitor traffic. So we do this all the time with security. With security, or with the devices that are just simply sitting there monitoring traffic. For example, this could be a database server, and this could be Wireshark. And Wireshark is just a packet analyzer, so all these packets are getting funneled through to Wireshark. And then when they're getting here to Wireshark, Wireshark's just allowing us to analyze these packets. Someone calls them and says, hey, that web server is slow, or that is slow. Again, this gives us the capability of monitoring what's slow and doing some analysis. Or again, with an IPS or an IDS, monitoring that traffic and alerting on potential problems. They can act as proxy servers. Proxy servers, very similar to what we talked about before with content filters. So within a proxy server itself, again, we have a switch out here. And in that switch we have a device, could be a server, and we have a workstation that comes through, hits this switch. This switch can act as a proxy to the server. And actually, when we do stuff like that, we're usually not just doing a simple proxy. We're maybe load balancing, or running this through some kind of a security filter. But this switch actually makes the response. So in reality, in what this actually looks like, there would be a kind of a line drawn here. And then when this workstation queries this server, the proxy gets it, and the proxy actually makes the query. The response comes back to the proxy, and the proxy responds back to the workstation. That's how a proxy works. So the workstation never actually communicates directly with the server. Again, the workstation comes over here, communicates to the proxy. The proxy then makes that communication here. The response comes back to the switch or the proxy, and then the proxy responds back to the workstation. Oops. And these can also act as AAA servers. Remember, this was authorization, accounting, and authenticate. They can act as AAA servers. Remember, this is authorization, authentication. And they can act as AAA servers. Remember, this is authentication, authorization, and accounting. So remember, they can actually act as these, have this capability in the switch. Authentication. A couple terms you're going to have to be aware of along with this is IDS, IPS. Now this is, we discussed that intrusion detection system. Intrusion, this is and what these systems do is they identify malicious network traffic. I see. You can tell I'm not in it. MAL ICIOUS. They can identify malicious traffic. So when we talk about IPS, IDS, that's what they're trying to identify, the malicious traffic. There are two types of IDS systems. And remember, an IDS system that they're going to notify they just notify, they don't stop. And the two types we have are a host intrusion detection system. These actually sit on a server. And then the last one is a network IDS, and these actually monitor a network. And this is where you might have it as part of a switch. The abbreviations you have to get used to with this is NIDS, NIDS, and this would be an HIDS, a HIDS or a NIDS. So you'll see those abbreviations. Remember, you want to know what these abbreviations are, because on the exam, sometimes CompTIA is going to ask you, just put these abbreviations out there, and if you don't know what they are, you're not going to be able to understand what the question is. They're not trying to be tricky. It's just that's what sometimes you can't ask a question without putting the whole concept in there. People just know what it is. So the best way to do that is to simply put in the abbreviation. An IPS, or an intrusion prevention system, these actually are designed to stop attacks. So they can notify you, but they will actually stop the attack. That's what they're designed to do. These typically are inline devices. And when we talk about inline, we're talking inline device. You have the workstation is trying to get here. You might have a switch, and then here you're going to have your IPS. And then from there, your servers. So the malicious attack that comes through, makes it to the switch, hits the IPS, and the IPS stops it. Now, just like with the host IDS, we can have a host IPS. And they do different things, but those are the two types of systems we do have. And we did talk about this briefly. I'll just go over it again. Port mirroring. You'll see mirroring and spanning doing, excuse me, both are terms that you're going to hear interchangeably. They are the same thing. Some call it mirroring, some call it spanning. But again, in this situation, you have a switch, and in this port of that switch, you're going to have a device. It could be a server, it could be anything, and in this, you're going to have some kind of a monitoring device. And as traffic comes in to this switch destined for this server, a copy gets sent down to this port here and into this monitor device. And then when this switch also the server responds back, going back out, a copy of that traffic also can get copied here. So you can again, copies going in and out. In some cases, you might want to you can actually configure it just to get all incoming or all outgoing. But as a general rule, we like to have both incoming and outgoing to this monitor device. And this monitor device is actually used for some kind of analysis of traffic. I did mention, we talked about proxies a little bit ago. There are two types of proxies that just be aware of the definitions of them. Again, it's not something you're going to have to worry about a whole lot on this exam, but a proxy server, there are two types. One's called a forward proxy. And this acts on behalf of the client. And a reverse proxy acts on behalf of the server. Just know what those two definitions are for the exam. That's it for Chapter 11. Chapter 12, is IPv6, and we'll cover that. There's some very specific things you need to know about IPv6. It is not a significant part of the Network Plus exam. So we will cover it. There's certain things you do have to know about it, though, and it's one of those protocols or one of those technologies that you want to get familiar with. It's not widely used in the United States outside of very large corporations or internet service providers, but it is becoming more and more common. You'll see these occasionally, even built into your Microsoft Windows operating system. By default, IPv6 is turned on. So we'll discuss that in the next video, and after that we'll go remote connectivity, which is Chapter 13.